Welcome back to Algebra 2, Chapter 6, Section 4 in this book. And what we're going to be talking about is factoring polynomials and solving. Now, let me preface this by it takes practice, and if you need to, while you're getting started, look at the answer. If you're like, I have no idea, go look at the answer and see if you can figure out how they got it. Because so much of this, I was telling my son, I was like, I'm not really looking forward to teaching this. And the reason why is so much of this is a gut feeling. You look at this and go, oh, I think maybe to try this. And the more you do it, the more you sort of realize what you're supposed to do. It's one of those irritating things in math that aren't step 1, step 2, step 3. But look at it, try this, try that. Oh, that didn't work. Let's try something else. Let me explain to you what I mean. So say you have this, x to the third power plus 27, and you want to factor it. Well, that's confusing. This is to the third power, that's 27. You can't pull it first. You check to see if there's anything you can pull out. Nope. But you'll start realizing that 27 is a cube. It is 3 cubed. So then, now we have cubes added to each other, and it has one of those special patterns I don't want you to memorize yet, but I want you to start looking for and using, and that's going to make it where you do understand it. So you've got the special pattern on the bottom of page 345, the sum of 2 cubes and the difference between 2 cubes. So take a look at those. And this is a special pattern, the sum of 2 cubes, and then you go find the pattern, and then you will see how to fill it in. It'll say that, if this is A, that you write it here, and then you double it there, and stuff like that. And you go fill it in. Now, but remember, here's another one. Remember what I told you, is first you look to see if there's anything you can pull out. And on this one you can. Now, your book used U's. I don't like weird letters. I like X's and Y's. They work with me. They don't get turned into anything else. So 2 goes into both of these, and x squared. So I pulled out a 2x squared, which left 8x cubed minus 125. 8 is 2 cubed, that's x cubed, and 125 is 5 cubed. So this is a difference between 2 cubes. You go find the pattern and you fill it in, and these are considered the answers. Okay? Now and all of this is really what I sort of think of as more a pre-calculus skill and more of a college algebra skill. So if this is extremely hard for you, do not get frustrated. Give it a try. Do your best. And I'm also going to be showing you ways to kind of use your calculator to get a clue on how to do these too. So, and I'll explain that in a second. So, I'm just trying to calm you down. Alright, so there's another thing called factoring by grouping, and I did not learn this till college. So here is an equation. You cannot pull anything out. But if you could divide it in half, you can pull out of the front half an x squared, and out of the back half you can pull out a 9. When you do that, what got left over was the same. We can think of this like a unit. We have x squareds of these minus 9 of those. And so we can put the part that got pulled out together and the part that got left together. And this is the new answer, except that is the difference between 2 squareds. So it's plus 3 minus 3 and x minus 2. Now, see how it says in solving? And that's where I'm telling you you can use your calculator to cheat. So if we were to graph this, this line would cross the x-axis at -3, positive 3, and positive 2. We know it has 3 answers because of that third power right there. Tells us there's going to be 3 answers, and there they are. We'll talk more about when they're real and when they're imaginary later. But you could graph this, stick that in your calculator exactly like that, and you can do y1 equals this and y2 equals 0, and you could get the solutions that way, that it's -3 positive 3, positive 2. And then from this, you know how to change the sign and get back here again. So you can do that. You can graph it. You can also, on your calculator, do second trace and get zeros. These answers, these solutions are also called zeros. So there are a lot of ways you can get this answer on your calculator, and then that will help you start messing around with the equation and getting the answer. I used to tutor this one boy, and he did not like trying something and it being wrong and then having to start over. But with this part of math, it's part of the process. You'll say, well, maybe they're cubes, or maybe I can pull something out, and you do it, and no, it didn't work. Tear up that piece of paper, try again. So sometimes it's trial and error. So here's one, and here, this is to the 5th power, so we can have 5 answers. We look what we can do. We can pull out a 2x. This is what's left. This, you factor it, pretending this is a squared and this is a 1. So we get x, so it would be, because you can multiply to get 12, positive 12 is 3 and 4, added or subtracted is negative 7, but then these are squareds because that's a 4th and that's a squared. And then these, now we can set them all equal to 0 and turn them into solutions. So 2x equals 0, and so you divide both sides by 2, it's 0. And then x squared minus 3 is 0, so add 3 to both sides, take the square root of both sides, and you get these two answers, plus or minus the square root of 3. And then you get x squared minus 4 is 0, add 4 to both sides, x squared equals 4, take the square root of both sides, square rootify it, and you get x equals plus or minus 2. So if you graphed that, you would see 5 places, and you could see what they are, to figure out what are my factors going to be. So a lot of times you can work off of your calculator to get a clue of where to start. So do the best you can, use your calculator all you can, come back and we're going to talk about something called the remainder and factor theorems, and one of my favorite things, long division of polynomials and synthetic division of polynomials. That sounds fun. Math is great.